good afternoon. My name is Shivadeep. Thanks for joining the talk. My name is Shiva. I'm based in Netherlands. I work for ING. It's Dutch-based bank. I was originally Oracle database administrator, other part of the world. But from past few years, I'm more and more busy with automation, Ansible, shell scripting, Terraform, CI/CD pipelines, and one of the interesting topic these days, which I'm exploring today, these days is databases on Kubernetes. So, like 2.5 years ago, I don't know nothing about Kubernetes, nothing about CNCF. So quite new compared to all. So before I start, let me ask, how many of you work with Kubernetes on a daily basis? Like, yeah, everyone, almost everyone I see. And how many of you are like from the database background or data engineers? Okay, I see 3 hands. Okay. Um, so coming from Oracle background, here I am talking using GitOps agents and Postgres operator, database operator, how as platform teams, how we can build DBaaS, database as a service kind of solution. You will see a lot of ING, as I said. So you will see a lot of orange in my slides. This is the agenda. I will talk a bit more about databases on Kubernetes and the different operators. And this particular operator, which I'm using for this demo, CNPG, Cloud Native Postgres operator from EDB. And quick intro about GitOps, Argo CD. And finally, let's look at the demo, the prototype. By the way, at ING, we do deliver Oracle database as a service, but it is nothing to do with Kubernetes or nothing to do with CNCF. So this is what this prototype came up as part of exploration. If we could offer something similar with Postgres on Kubernetes, DBaaS solution. So when did people started running databases on Kubernetes? So after the inception of Kubernetes around 2014-15, the first official operator came from Crunchy data around 2017, and around 2018, one of the good ones, which is still going strong, is Zalando. How many of you used Zalando? Wow, wow, wow. So it is still going strong, right? Quite some hands. And around 2020, under the umbrella of CNCF, there is a new community, which is data on Kubernetes. So this community is encouraging and following upon the topic of data on Kubernetes training and community meetups, and also every year they do survey and publish a report. And another thing I would like to, the operator which I'll be using for this demo is CNPG operator. It is from EDB, Enterprise DB organization, and it started around early 2022. And yeah, the DOK community says 70, it was a statement from 2022 already, like 70% of companies run their stateful workloads on Kubernetes, but it's like 70% of what they surveyed, I believe. But coming back to the question, like, does people really use, as per my original impression, I thought databases on Kubernetes could be maybe for a sandbox environment or could be for dev or test use cases, but does people use for production? Like I saw a lot of hands for Zalando operator. People do use for and a Dutch Chamber of Commerce, Dutch government body, is also using a Zalando operator in their production. And last year in KubeCon, they had a separate track for DOK talks, and HSBC, the bank, they also gave a talk, not their entire landscape, but they do have workloads, production workloads running on Kubernetes. They are using not Zalando, but the CNPG operator. So this evolution timeline is still old from 2024 from Percona, but still, yeah. Meanwhile, there are many more operators. You could see one from Mongo, Cassandra, Stackgrace. So there are more and more operators, and also there is one from Oracle. So did anyone know Oracle has official database operator for Kubernetes? So there is one. It's called Aura operator. And one of our sponsor, Nutanix, have also NDB operator, which can manage not just Postgres, but it can manage multiple databases: Postgres, Oracle, SQL Server, and MongoDB. Let's spend a minute on CNPG. Yeah, there is quite some content, but focus here. So CNPG operator is from open source Postgres operator to run Postgres on Kubernetes. This is from EDB, Enterprise DB. It started around 2022, and it got quite some acceptance and adaptation in the market. But it is still in sandbox maturity level, and it has, as per last month, around 8,800 GitHub stars. It has quite some capabilities. I just listed a few, like automatic failover. You can have primary cluster and standby Postgres cluster. If something happens to primary, it automatically failovers. And you can do planned switchover when you have planned activities on primary. Given the configuration, operator automatically does the PVC management. It creates the PVCs and manages it. And there is also something called delayed replica cluster. So if you have primary cluster, you could create another cluster as a clone with a timestamp in the history. So kind of a point in time. And everything is declarative. In terms of adoption, as I was saying, this particular operator, if you go to adopters, here documentation is quite clear and very good documentation, and GitHub, this is completely open source. And if you see the adopters page, you will find Microsoft in there, Google Cloud, Belastingdienst, basically Dutch tax office, there is Tesla, Novo Nordics. So it is kind of slowly becoming kind of industry standard, because more and more big names are using it. And this is a sample definition of bare minimum Postgres cluster. So cluster is a CRD, basically a CRD, and here we are mentioning name of the cluster and namespace in which it has to be created, instances 1, which means no replicas, only primary instance, and size, so size of the PVC volume. This is like bare minimum example of a Postgres cluster for CNPG operator. But we will look more GitOps. How many of you already use Argo CD? Every one of you. I mean, almost 75% of you. So just for the other 25%, GitOps is a framework to deliver what you want to have. So in other words, GitOps agents look at your single source of truth, your infrastructure as a code in a GitHub, Git-based version control system, and it provisions your infrastructure depending upon that single source of truth. It's not only the provisioning, it's also automatically reconciling. If I say hand with 5 fingers is my single source of truth, this is how my infrastructure should look, it creates. And next day, if I say change it to this, it automatically reconciles. That's the main purpose of a GitOps agent, right? So Argo CD, Flux are most famous. For this prototype, I'm using Argo CD. Coming back to self-service and something as a service, as platform teams, there are multiple ways to provide something as a service, right? You could have UI-based application, for example, from BMW talk from BMW people this morning. In their lessons learned, they said like, API-based provisioning is better than UI-based, bettering for their environment. So there are a few ways, like you can have UI, you can have API endpoints. So if you want to, as platform team, provision a VM as a service or a namespace as a service, you can build an API and create an endpoint with some expected payload. Then consuming teams can hit that endpoint with the payload, and then you do the provisioning automation behind it. For this prototype, API could be a little bit more. So I am following using GitHub. So basically, you could say master is the main single source of truth. That is where I am defining my infrastructure. But you could say you could create a template, user-friendly form for consumers, and consumer-friendly readable form, and you could say fill in those key value pairs, and then merge it to main. Then we do the provisioning. Let's look at it in action. This is just what I have in the prototype. So I have a Kubernetes cluster in my local machine. This is one node. I am using Kind. I don't know, Minikube. I never tried Minikube. I always tried Kind. So it basically creates a one node Kubernetes cluster. Anyone of you heard harness before? Okay, I see 2 hands. Okay, it's like Jenkins or Azure DevOps, basically software delivery tool, or CI/CD, GitOps as a service tool. It's cloud-based SaaS solution. So in my organization, we use Azure DevOps, but for this prototype, with free tier account, you could do quite some stuff. You could run CI/CD pipelines and configure GitOps agents, as long as your CI/CD runner is in your own infrastructure. In this case, my CI runner is running in my Kubernetes cluster, and also I have a GitHub repository. As a platform team, I'm calling it as Shiva data platform, and I have link between the harness and GitHub with PAT tokens, personal access tokens. And I have Argo GitOps agent configured, basically configuring, saying this GitHub repository as source, and this is the target cluster. So Argo CD runner is also running in the same Kubernetes cluster. And I also have the CNPG operator configured in my cluster. Very short demo. Basically, I'm showing what I have. So Kind at the backend, it creates one node cluster by default, but it's not a one node. It's basically a Docker container in the backend. Sorry, it's very small for people sitting at the back. Please excuse. So basically, I did kubectl getNS, and I have few namespaces. CNPG system namespace is where I have the CNPG operator installed in my cluster. So if I say kubectl get nodes, it's basically one node cluster. This is not a node. This is a Docker container again. That's how Kind sets it up, right? This is the UI of harness. So there are quite some things which I didn't explore, but pipelines, where you could define your CI/CD pipelines, and executions are the actual runs of the pipelines. And there is also GitOps section where you configure. Here in harness, you could either choose Flux or Argo CD as your GitOps agents. And as I said, I have a GitHub repository. I'm calling it Shiva data platform. There are a bunch of stuff. The main, one of the important thing is datastore.yaml. This is like template key value consumer-friendly file, I would say. So in the README, basically I have for consumers update datastore.yaml to request a database, a Postgres cluster. And this directory, manifest CNPG directory, is a directory where Argo CD agent is watching. So it is watching for source of truth from this directory. So I have repository, something for CI/CD and GitOps, and I have target Kubernetes cluster. That's what I wanted to show. And as a consumer, you could say, as a platform teams, you could say consumer, if you want a request a database, create a branch from main branch and fill in this human-friendly, consumer-friendly form. I will show you in a minute. So he would create a branch and fill in that form and create a pull request. So basically, as a consumer, I create new branch. I am calling it consumer1. And in consumer1 branch, I go to this particular file, datastore.yaml, and this is what my platform team, which is me again in this case, gave a template, kind of a template, which says basically asking me to fill 5 fields and some explanation around it. So team name here is basically, it's not a cluster, but the namespace name in which your Postgres cluster will be installed. And cluster name is the name of the Postgres cluster. I'm calling it recruitment1. For example, as platform teams, you could have the t-shirt sizing like small, medium, large. So, and you could, for example, in this example, small means 256 MB, medium 260, large 270. And you can say data store types for this prototype, there is only Postgres, but yeah, you could have more flavors. And you can also have concept of service levels like platinum, gold, or silver, gold. So here, description is a little wrong. When I say, for example, if silver means instances 1, which means only primary, no replicas. Gold is instances 2, which is 1 primary and 1 replica. So consumer need not need to know the Kubernetes manifest style of filling. What is the size? Should I mention MB or MI? What is instances 2, 3, or which CRD item I should fill? So they don't need to have that exposure to the operator manifest file Kubernetes or operator expects. It could be a friendly, consumer-friendly key value form. So he filled in, and he created a pull request. So in harness with pipeline, there is also something called trigger. So I have a GitHub trigger configured. So which is basically if there is a pull request to main branch, my pipeline would get triggered. And as part of this pipeline, basically I am translating this key value consumer friendly form into a proper manifest file, which Kubernetes and operator could understand. Let's look at the pipeline. I'm calling it translator. It basically has 2 steps. One is a Terraform module, and other is a shell script. So in this Terraform module, basically what I am doing, and I see some giggles. You might have find the pad tokens in plain text format mentioned in my pipeline. That is not something to do good to do in your production. So 2 steps in Terraform apply. In first step, I am basically converting these 5 fields into Kubernetes understandable manifest file. So size small means 256. Service level gold means instances 2 or 1. Team name is namespace name. So that's how I'm mapping and creating a manifest file. And in the next step of shell script, I'm creating a new branch and merging it, creating a new branch with this manifest file and merging it to master branch. You could directly, as platform team, if you trust your automation, you could have directly merged it to main branch. But just for the prototype, just to see, I'm creating another pull request. The pipeline is creating another pull request automatically with some auto-generated name, and in that you would see not the 5 fields consumer has filled, but a manifest file which is derived from the inputs of the consumer. So if I click the file change in the pull request, it's not what consumer has filled. I'm calling it as generated Sofico. So he has filled cluster name as consumer1 and namespace team name as Sofico. He chose silver, that's why instances is 1. and chose size as small, so that's why 256 MB. So as platform team, we trust this manifest, and then we merge to master. So I'm adding this manifest file in a location where my GitOps Argo CD GitOps agent is watching. So now Argo CD agent knows there is new manifest file in the single source of truth, but there is no equivalent resource in the Kubernetes cluster. So it actually does the kubectl apply. So it is not Kubernetes native component which I'm creating. It is a CRD from this operator. So with the help of operator, it understands it has to create a Postgres cluster. So let's look at it. So I'm coming back to harness again. So there is something in harness. First, you have to configure repository. Basically, link from your harness to the GitHub repository. This is the link. I'm saying this. Use this as source truth, and you have to have an application. So basically, link from source to the target. So this is the GitHub repository, and target is the local Postgres cluster, and this is the path which Argo CD has to watch. And it already, if you observe, said out of sync. Technically, Argo CD can automatically keep syncing, but just for this demo, I have configured it as manual sync. So it won't automatically sync, but we have to go and, so I really like this view, resource view, with easy to understand. So each component running, each resource running in your Kubernetes cluster, you have equivalent component in this view. For example, yeah, let's go to the terminal and see. Now I am running kubectl get all from CNPG namespace. There is a pod, there is service, deployment, and replica set. So each one would have subsequent box in the resource view. And for example, I'm seeing get a service in that system. So there was some webhook service. So if we go and search, yeah, here CNPG webhook service. So that resource maps to this box in this graphical representation. And as I said, it is already out of sync because I didn't set it to automatic sync. I said manual sync. So let's look what is out of sync in this resource view. The consumer one. So Argo, as we added the manifest file, it already recognized there is a new resource which it has to create. And it is not there in the cluster, but it is there in your single source of truth. So as I configured it as manual sync, I have to actually go here and click sync. But technically, it could be automatic. Just for the demo purpose, I set it to manual. So now I go here and click sync. Oh, before that, let's compare what we have now. If you see, there is no namespace with the name Sofico. So now if I go to this box and click on sync, while syncing, you could select which particular component you want to sync. So for now, I am only syncing the one which is out of sync, which is with the red mark. And I'm clicking little checkbox saying if the namespace is not already there, create one, auto create the namespace. And then, and here the source to GitHub repository, this is all automatic the way we configured. So now as we clicked on sync, now GitOps runner is busy applying the manifest file. And actually we can see from this view what exactly it is applying. So if we go here and click on details, yeah, manifest would be the full definition, but to see the difference, what I have and what I'm changing. So particular to this, there is nothing on the cluster, no Sofico namespace, no Postgres cluster, but now it is busy applying this. So basically the same manifest, it just added a label in the metadata section so that Argo CD runner could recognize. So now there was no namespace with a name Sofico. Now if we do kubectl get ns 90 seconds ago, there is a Sofico namespace. So it is busy under the Sofico namespace. It is, if I say get all from Sofico namespace, yeah, there is a pod which is in pending state. There are 3 services which automatically operator automatically creates, and there is a job which is running. So in this case, as we choose instances 1, it doesn't make sense with. So basically, there are operator automatically creates 3 services: read write for primary, read only for standbys replicas, and read could be, and it could either route to load to primary or standby. So in our example, we are chose instance 1, so which is only one instance. So all these services will be pointing to one Postgres cluster instance. So operator automatically does that. It is still busy. Okay, pod at least came into running state, but it is in initdb. So cluster is the CRD which from the operator, and if we could view the status of particular cluster. So name of the cluster is derived from the form consumer has filled, consumer1, and it is still setting up primary. But after a few minutes, if we go, come back to this view and see, it says synced, green heart symbol and blue tick mark. So it applied with the help of operator what it has to create. So basically Postgres cluster, a PVC volume, these services, for example, are read write. So each resource in the cluster have equivalent component here. A pod, PVC volume, so it operator automatically generates. So we chose size small, so which should be 256 MB. So if we go back to terminal and if we say get PVC -n Sofico, so it created with size 256 MB. So this is with the help of GitOps agents and operators like CNPG. This is just the part of provisioning. But yeah, now it created a Postgres cluster for consumers to consume. Again, quick recap. Consumer filled in a form which is human friendly. He doesn't need to understand the manifest structure. So as part of platform teams, we using a pipeline, we translated it and converted it into proper manifest file, and we merged it back to the main branch where Argo CD agent is watching your truth, and it actually applies in your Kubernetes cluster with the help of database operator. It finally delivers your Postgres cluster. This part is only provisioning, right? So as this operator is is declarative, like there are other things. So this is the simple example which we use default. And as platform teams, we could also tweak fine-tune parameters related to Postgres instance itself. You can say service level gold means auto vacuum 5%. If it is silver, auto vacuum 10%. People, okay, you said you work with Zalando, right? So you know definitely about auto vacuum and analyze jobs. So you can tweak such parameters, and it is all declarative in the same manifest file. And you can, with this operator, you can also configure your backups to AWS S3 storage, for example. In this example, it is S3 storage with AWS secrets. Creating a database, creating a user, removing a user, it is declarative. So point I want to make is, it is not as scary as I thought to build database as a service, especially with help of excellent tools like Argo CD and CNPG operator. So this is me, that is my LinkedIn profile, and you can find my slides and my blog. This is the QR code. Thank you so much. Please, okay, it is going back to the previous slide, I don't know why. Please do share feedback.